Bloop. And we are going to do some more line integrals today. Of course, unless you have some homework problems for me, you tell me. And no, good, great. Let's keep moving then. So, um, I've already did most of these before class. I got stuck on one, and then I had to go to the homework and get help. And that's okay sometimes, right? That's okay. And it was a very silly little thing I did. So just as a recap of what we're doing here, we're doing all this blah, 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 blah. But the main thing is right here. I like this one the most. We're doing, oh, I need to draw. We're doing this FDR thing. Let me, real quick, go bloop, right here. That guy. He's our happy times, okay? That doesn't look happy, Chad. Now he just looks angry. Little tooth. Anyways, yeah, we like him. He's cool. I'm actually going to use this formula here at the bottom also because it'll come up later. This guy, he's the other one that I'll be using today. And I'll explain that a little bit more when we get there. One more thing. I don't know why they call it flow, which is fine, but then it's also circulation. So like their equivalent, if they say circulation, this is what they mean. If they say flow, this is what they mean. And what this is, as we've seen above, this is the FDR. It's the same thing. It's literally the same thing. It's equivalent. If you go back up here, see, they're the same thing. So we like that. Cool? In a way, we're going to just do the same thing again and again and again, but this time we're actually going to do the real stuff. And that makes it fun. Okay. But first, of course, we got to do something that's not the real stuff. I want you to do this so literally that you're almost scared because it's so easy. Okay. So literally, when it says X, what do I put for X? Perfect. When it says Y, I do what? Perfect, perfect. When it says dx, what would be dx? dt. Very good. That's it. It says so. It says so. I know. It really is that easy. So if they give you like a dx or a dy individualized like that, you just do what they say. What is that? Negative 6t minus 2? And what would be my integral? From 0 to 9, plug it in, negative 216. I don't know, what was it? Okay, well, dyslexia. I was just trying to remember from earlier. Yeah, I know, but when you're so close, it's still wrong. So, blah, 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 yeah. We just did it literally. When it says dx, you do dx. This is not what we're going to be doing all day, but it is something that when they ask, we can do it. So that's not too bad, right? Makes me wonder if there should be a you do next. I didn't know you do energy drinks, bro.
Dude, I've been drinking one almost every day this semester.
Oh, cool.
Yeah, like,
Well, I've seen you occasionally, but then we're coffee friends, huh?
I alternate between coffee.
Oh, okay. Okay, that's cool. So, are we good with this one? I want y'all to think about this one. Now, what's happening is that there's two different integrals. It's going to be integral blah 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 plus integral blah blah blah. I want this is a you do for just a tiny bit, okay? And it needs to be literal. It needs to be literal. Try at least one of them. You can do the first or the second half. I don't know. I'm gonna call this I1. And I'm gonna call this I2. That way I can like differentiate between the two things. Just try it out. Do it literally. And if you wanna do that approach here, it might work. When I did this one before class, it was easy. It was easy. But you have to think about it just a tiny, tiny bit. No problem's identical to the last one. Gosh, man, that's a perfect time for me to sit down. Ah, is this what it feels like to be a student? No, because y'all have those stiff chairs that not fun at all. Yeah. I would hate to be so mean, especially when recorded, but I could say, well, but Mason doesn't want to sit in one of these chairs. He's like, oh, my arm hurts so bad. I just thought I know. Sorry. That was a bad dig, bro. I'm so sorry. I know. No, you're fine. You're fine.
I don't know if I got it right, but I got something.
Good. Something is the answer. I don't think it's 0.
Right.
Are you done too? Oh, okay. Remember, it's all in the setup, right? It's the setup that's making this thing kind of different. I'll attempt it. What I need to do is make an x and a y for each one of these separate integrals. Like, I don't have an x and a y equals thing. So, like, okay, for this I1, that little section there, I need x equals and y equals. But tell me just, what is y equal to right here? That's easy. I'm taking it literal. Now, eventually you know how this is going to work. We're going to need t's. So give me an easy x equals what for t? Yeah. I know. It's just that easy. It really is. And I'm going to do this one literally. So we go, I have x squared. That's t squared. I have y squared. So that's 0 squared. And then it says dy. What would be my dy in this case? 0. Okay. Like, I don't know, that this whole thing right here turned into a 0. That was a 0. Okay. So I guess we have to do the I2 part now. For this section, again, we need an x equals and a y equals. What is x equal to all the time? No, what's x equal to? Just right here on this little line here, what's x equal to?
Oh, 0.
X. 1. See my x terms? Yeah, so just 1. Just 1. Now, give me an easy thing that we can use for y here in terms of t. Easy. Close. You can do that if you like. I'm not a fan, but it works. Is there another alternative? Keep it easy. It's t again. Oh my gosh. Now, what you could do is 3t, because you're going up here to 3. That is also, and I'll do this one this time, but just a t is fine. If you're gonna do this road, then you're gonna have to say that your t is going from 0 to 1. If you don't have the 3, then it's going 0 to 3. Right? As long as you get up to the 3, you should be fine. I know we're gonna have a dy, so let's go ahead and do that. What's dy in this case? Yeah, 3 dt, exactly. All right, so let's try this one now. So it says x squared, so that's 1 squared. It says y squared, so that's 3t squared. And then I got dy, which is 3 dt, 0 to 1. So what we have is 1, there's a 3 on the outside, 1 plus 9t squared. I need to take my integral. What would I get? Oh, you're already on it. T. Very good, very good. 0 to 1. When you plug that in, you just get 1s in those cases. So yeah, 12. So basically what we have is 0 plus 12 is 12. Flash the answer, and it's 12. And you could see I did it too. I went from 0 to 3. You can go 0 to 1 as long as you're going times 3. You get the same answer. It's up to you how you create it. Now, I gotta say, this kind of ran against my my math origins. Yeah, I did not want to do 0 to 1 or 0 to 3 on this. I wanted to go 1 to 4. I wanted to go 1 to 4 on my t because I already said that this was t equals 0, t equals 1. So I wanted to say that this was t equals 4. Do you get that point there? But then if that's the case, what would these guys be? Yeah, you got a 1 there. But this one here would be different. You'd have to subtract something to make it work, blah, 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 blah. Who cares? Right? Who cares? So that's my suggestion. Simple as possible. Good? Any questions? Those were the easy ones. Those are the literal ones. When it says something, you do it. That's it. This guy is not as straightforward. He's still very simple. But this is the first time that we're going to do the real FDR now. And I'm going to remind you what that means is that I got f dot r prime dt. Okay? I'm going to take a dot product with f and r prime. Okay? So we have an f vector. That looks legit, doesn't it? I have r, but I can find r prime vector. What would that be?
Wouldn't that be a cosine t?
Yes.
Negative sine t.
Cool.
And then just 1.
Perfect. All right, here we go. Integral 0 to 2 pi of 4z, 4x, 4y dot all that stuff that I just had. Hopefully you're going to run into a problem here in a second. It's a perfect opportunity to learn. Like, I don't want to do too much more math without something helping me. It's not exactly in a nice format. Yeah, it will. We cannot retain those x, y's, and z's there because I'm supposed to have everything in terms of t. Surely there's a way to replace those. Do we have a formula for x, y, and z?
All right, we gotta go polar.
Not this time. But that is kind of funny. Surely we have a formula. No? Yeah. That's closer. Here you go. You ready? R is x, y, and z. Thus, this is x. This is y. This is z. Those are your formulas, and now you're hating me. Like, it's almost too easy, right? It's almost too easy. So this right here would be what? What do I replace this with?
That would be sine t.
No?
Oh, wait, no.
It's in orange.
Yeah, it'd be
Yes, t, exactly. And then my x is a,
Sine.
yes,
Cosine.
very good. Watch out, because man, how many times have I flipped those?
Yeah.
Right?
Because you have an order like that, you can flip the order
Yeah,
around.
exactly.
Yeah.
What the problem that happens so much, and it's an often caused thing, is that we look here at our math and we say, "Oh, this is my x, this is my y," but that's x prime, that's y prime. That's a little different. So yeah, we're using our original to go and plug it in. So I'm gonna do my dot product now. I would get 4t cosine of t. That's going to be a minus this time. Minus 4 sine of t. Sine of t, so it's just squared. And then the last one would be 4 cosine t. dt, 0 to 2 pi. There we go. You okay with that? Happy times? One of these is unhappy, though. Yeah, actually 2 of them. This guy right here, grr. This guy here, formula. So let's get to it, I suppose. I'm gonna do my integration by parts thing here, and I probably could just get this answer by just looking at it, but well, it's best to write it down. That way, I don't get it wrong. So then I would have uv. Oh, hold on, I already took the integral of this guy now. Okay, so I've got uv minus integral of v du. So that's just this chunk that I just did there. And I'll come back and do that guy in a minute. Sine squared. You're so familiar with this at this point. Oh, I mean putting the theta. I'm so familiar. Is sine, okay, hold on. Was it the minus or the plus? The minus? Okay, I'm gonna go and check it. Okay, here we go. I'm gonna check it. It's the minus. You're right. And then finally, this one's easy. What's my integral? That one. Last one. Beautiful, beautiful. Okay, from 0 to 2 pi. And this integral here would make a positive cosine in the end. Am I right there?
Yes.
And this,
Negative cosine with negative cancel out, making it positive.
perfect, perfect. I could distribute this guy. Well, actually, I distribute both of them technically. -2, so 2 negatives make a +2. And then this is much easier to plug in. Hopefully. So anything with 2 pi or 0, the signs are going to not work. So really, we're just left with this guy, which is kind of nice. When I plug a 2 pi in here, I get a 1. And then I got -2 times 2 pi minus, plugging in the 0, I get a 1, and then I get a 0. Bracket. The 1s are going to cancel. -4 pi. Flash the answer, and there we go. But you already had that answer a long time ago. Really? Oh, did you just stop writing? Oh, okay. I mean, are you good with that? Hmm. Cool. Exactly. Yeah. Right. This is F, and this is R prime. Exactly right. And that, I mean, that's again weird because we're using r to plug in, but then we have r prime to multiply it. It's like we're using three vectors, kind of, not just two. Good thoughts? I can't read your mind, so.
I'm looking at the next question.
Oh, well, that's why you have a face on you.
Yeah.
I love it. Is it the one that I messed up? Probably. We'll see.
Yes, the TDS.
We'll see about that. Yeah, DS. I don't like DS. Nobody likes DS.
Yeah, well, my first thing is YCT, and I go back to section 13, where you have to take like all the things to find T.
Not fun, right? Not fun. Hopefully Chad has an answer for all that. Are we good though? Good? Good? Okay, yeah. Next one. Yeah, DS? No. So pause for a second. Like I said, every single time we're going to go back up here and oh my goodness, I have it. It's actually FDR, which we just did. So we're doing it again. So just ignore this, and it's integral of FDR is what this guy is. That's all. Well, that's kind of nice. See how I make it easier on you? Yay. Thank you, Chad. So I need to find my F vector and all this kind of stuff. I think the F vector is pretty easy. What would I say my F vector is just with X's and Y's? It's almost too easy. I know, you're just copying this down, Chad. Yeah, I know, but don't you get confused with the I's and the J's?
Actually, that's how I've done the entire semester. I'm like, I don't even look at I's and J's. Just
Oh yeah, the alligators, right?
Yeah.
Exactly. Yeah, don't even look at I's and J's.
I don't know why, it just confuses me more.
So without going down that road for a minute, I want to look at this guy and I want to get my R. My original R. As in, like, this is going to be X and this is going to be a Y. What is X equal to? Make it funny. Y squared. What is Y equal to? Y is equal to Y. I know, right? Well, we have to make up a T. Did I just say make up? Make up a T. So then, what would be the easiest replacement here? Yeah, therefore I'd get beautiful. I love it. Blink, blink, blink. We do have to make something up at some point. We need T's. You pick a T you like. Because T, I mean, we always think 0 to infinity, but it's technically negative to infinity. We can do anything we want. Any T that is consistent and it works. So this is a good thing here. If that's the case, then it's super easy to find my R prime.
2T, 1.
Perfect. So we'll be using both of these with this thing, which actually at this point, I can just go and plug this thing in. If it says X squared, what would I actually be putting in terms of T now? Very good. Yep. See this guy right here? You're plugging it in. Squared. Squared makes a 4. And then on this side, we would have what? Negative T. Very good. Right here, I plug it in. That's a direct, just plug it in directly. We have everything. So T to the 4th, negative T, dot, and then over here we got 2T and then a 1. Dot product, 2T to the 5th minus T. And now, this is the last hump. It's always, in my opinion, it's always better to make a nice, easy, plain T that works with the math. But now we have to find the values for the limits of our integration, right? We have to find these, given what we have for T, okay? So we said that, ew, don't do that. we said that y equals t, or t equals y. And you can see right here and here. Yeah? Okay. So what would be my t values? Definitely a 0. I think it's just going to be a 1. And the reason why I'm thinking that is because we're wanting to get to this point here. We have a negative there. I thought there was a negative in there somewhere. Hold on. Let me go back to what my work is. Hold on. Yeah, I said t equals 1. I did everything that... Oh, yeah, I did everything that y'all did. Oh, no. If I plug in a 1, I don't get the 1 there. It is a negative 1. Well, maybe there is a negative. Oh, look, it is a negative 1. And I would get the same answer. Blah, blah, blah. You didn't see that. So, yeah, I was wrong. It is going to be a negative 1. Yeah, this is t equals 0, and this is t equals negative 1. Silly Chad. Now, also, and this is so important. This is so important. From 2, 0 to negative 1. Yeah? We're going backwards. That's fine. That's fine. Are y'all okay with this? Are y'all okay with the negative 1? Because, I mean, it says directly, and I just... Yeah? Okay. Would that make sense, though, if I plugged in a 0 right here? Would I get 0, 0? When I plug in a negative 1, do I get a positive right here? Yeah. Okay. So, yeah, let's do this thing. So, my integral here... yes. Oh, it is 1/3. You're right. Yeah. Thank you. Minus from 0 to negative 1. When you plug in your negative 1, again, 2 negatives will always make a positive here. We got negative, or I got 1/3 minus a half. When I plug in a 0, it goes away. And there's your answer, and I already flashed the answer, so we're good. Yep. There it is. I was wrong earlier. You fixed it. Thank you.
Well, the reason why I was thinking that is because if we have y equals t and we have a y there, it would be negative 1 over y.
Have to.
Yeah.
Yeah, I know. I was mistaken. You were good.
Thank you.
Thank you.
Broken clock is right twice a day, you know?
Well, you're not a broken clock, bro. You're not broken.
Chad, let me just joke around, okay?
Okay. Good job, though. Good job. Are y'all okay with this? Yeah? I know it's a little weird because I'm having to, like, put this in here and plug that in here and plug this, but it's better than Jacobians. You can at least say that. All right. So this guy, I got him wrong twice, and I did 2 different formulas, and I just did not know what I did wrong. And then I went back and looked, and yeah, it was just me doing something stupid. So we're going to do this fun problem. There are 2 different integrals, and they say 2 different things we need. Notice that we have this guy for the first one, and then this guy for the second one. The second one is very simple, because when you take a derivative, you're just going to go like 1, 0 thing. So I'm not worried about this guy. But what does it mean? Like, what are we looking for here? It says circulation and flux. So let's go back up. Here we go. Back up to the top. So, oh, there it is. There it is. Circulation equals FDR. So we're looking for FDR. And that's what I did the first time, and then I got it wrong. And then I thought, you know what? I think I'm going to use this formula right here, since we didn't have a Z. And I did this, and I got it wrong. Look, they're equivalent. They should be the same, right? They were the same. They were the same wrong answer. But it was actually my mistake, and I'll show you. It was a small, tiny mistake. It's easy stuff. So this is indeed what I'm going to do. I'm going to do FDR, but if you want to do that one, it's totally fine. I think this one's going to be more fun. Yeah, it's going to be more fun because what is the other thing they're looking for? They got circulation, but what else? Flux. They want this thing, which is not integral FDR. Now it's a variant. It's not the same though. We can't just say you're not going to get the same answer twice, essentially. Well, here's another one for flux, and right here, it looks very similar to this guy right here. Okay? So that's what I want to do. I want to do this style, MDX, NDY, and then I want to go back and do MDY minus NDX. Cool? This is very similar. I think we might see it soon. I think it's Green's theorem. I can't remember the exact one, but we're going to see this stuff all over again and again and again and again. One last thing. I want to talk about it before we go on. What is that circle doing there? Or even if I did this, I mean, I do integral FDR, but I don't do the circle sometimes. I don't know. What's the circle mean? And he's hanging out. He's just hanging out. No, there's got to be a meaning for it, right? Everything in math has a meaning. Take an idea. Okay. Silly. Give me a real answer. Okay, that was way too complicated. So say that again. Yes, that's getting down the right road. Go ahead.
I was thinking, since this flux is also circulation, does that mean like circular or something like that?
There it is. Circular. We're going around in a circle in a way. And I'm going to say more like a full circle. And this is just indicating line integral around a circle, around a curve. Full circle, often 0 to 2 pi, that kind of thing. Okay? So we're looking for the flow, the flux, the circulation, whatever you want to call them, for a complete path. A complete path. Yeah, for like a rotation in a way. Now, I know that this is not a full rotation, but like we're getting there. You're getting the idea of it, right? But how often have we had 0 to 2 pi? Here, that was 0 to -1, but 0 to 2 pi. These things I'm not going to say that you just say 0 to 2 pi, you can put a circle. It's not quite that way, but the idea is that you're going full circle around this thing, okay? There's also more behind it, but we're not yet there. I just wanted to say that's what they're meaning. Okay. So, we got two integrals yet again. We got an integral, blah, 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 plus an integral, blah, 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 blah. So I want to do the first one, which is the m dx plus the n dy. Again, I'm going to state that this is the same as the FDR integral. They are literally equal. I got the same wrong answer twice. It's great. So we're going to do it, and it's going to be great fun. But it's good practice for when we do the next guy. What do they mean by m is right here? They mean 3x squared. What do they mean by dx? They're saying, well, this is x and y, so then dx and then dy. You get the point? What you're doing is the dot product for FDR right now. That's going to be the dot product. You're mushing them together. You're saying, what's the derivative? Dot the original. So it is the same. It's equivalent. I'm just making this way over thought. So, without making it too crazy, I want to plug in the 3x squared, but it's not x that I want here. What is my x equal to? Right? But he's squared. And then I'm multiplying by the derivative. I need a dx. What would be my derivative of this a cosine? Okay. Good. Plus. And now I have, I have a 3. And then we have a y. What's my y equal to? Sine, a sine, very good. It's right there. And then I'm going to square that guy. What's my derivative of the y? Yeah, exactly. That'll work. And then all this stuff, I'm super picky about my brackets and stuff, dt. And they told you what t is. It's 0 to pi, so that's not too bad. Plus integral of negative a to a bracket. So I'm now plugging in this one here. So I want you to see what this is. It's actually this guy, right? Is it? I know that's right on the line. That's probably not really healthy. Let's try that again. T comma 0. So then what's my r prime for this guy? Perfect. So here we go. I've got 3 times, what's my x? Just t. Square it. What's my dx? Yes, 1 dt. Very good. Plus 3. What's my y for up here? What's my y? 0 squared. What's my derivative of y? Okay. And there we go. Well, then we don't need that guy. This is only a 2-dimensional. We're using 3 different things that we're plugging things into, right? It's like we got 6 little pieces of the puzzle, and you have to kind of plug this in to plug that in and blah, blah, blah. But in the end, the math isn't hard. It's just, where do I put my puzzle pieces in a way, you know? Okay, well, I like this integral. That one looks easy. This one, not so much. But is there something that I can take out from all of these? What do they all have in common? Let's leave the sine and cosine because they're attached with the t's. So what do they all have in common other than 3? A cubed, technically, right? See how they're squared right there? And so yes, I'm going to say 3a cubed in the front. Leaving behind, I've got cosine squared t times sine of t. And then that's a negative. That was a negative. Plus sine squared t cosine of t. And dt. And then again, on the bottom one, I could probably just get this done. What's my integral of 3t squared? T cubed from negative a to a. In fact, because it's like so easy, I'm just going to write it on the side now. So yeah, t cubed from negative a to a. Awesome. That's not a 9, that's an a. Okay, well that seems fun, because what kind of integration are we doing with this guy? U sub, and this one?
Also a U sub.
Sounds easy. I love it. So if u is equal to cosine, du would be a negative sign, which is already out there. So it's now going to be u cubed over 3 essentially. But now I just want to not have this, if you don't mind. I already know what u is because I'm going to have a v over here and everything gets messy. I'd rather just say it's cosine cubed over 3. I believe so, but I want to not be hasty about the SIGN sign. Right? Yeah, I know, right? The positive or negative. I know that was such a bad math joke, but it was really apt. Okay, it was really apt. So I'm saying u is my sine. Du would be a regular plain cosine. Yeah, everything's fine. So you're correct. Your SIGN sign is correct with your SIN sign, or should I say SINE sign?
I lost you. I just hear sine. That's all I hear.
So on my YouTube video, play me at 0.5 speed. And then you could probably hear it all. So we got this guy from, and we're going to be careful. This is from 0 to pi. Over here, we got a whole different dude. When I plug in an a, I get a cubed. When I plug in a negative a, and I'm supposed to minus it, I get negative a cubed. But you can already kind of see what's going on here. They're not canceling. They're combining. So a few more things. These 3's all cancel, which is happy times. When I plug in a pi, my cosine is retained, but my sine is not. So this whole thing goes away. So I get a cubed negative 1 minus 1. And then on this side, I get plus 2a cubed. What's my final answer? 0. I know, right? Because I got a negative 2. Yeah. Man, all of that for a 0? Doesn't that annoy you? Welcome to chapter 16. So, and I'm going to say it, I guess even recorded. If you actually have no idea what's going on, it is best to guess a 0. It truly is. A lot of them going forward, the answer is just 0, move on. You don't want to guess on the final exam, but if you had to and you really had no other time, 0 is the best. Okay? Good. Well, that was the first answer. Yay! Now we got to do the other one. I'm just going to put a 0 in there. So what about the flux? I have to do this whole thing all over again, but now with a new formula. It would be the m dy minus n dx. From the very start, I have to rearrange things. It's a bad sign when I make that laugh. So my m, as I know, is 3x squared. But what was my x for the first case? I'm almost copying this thing, almost. What would I have here? Okay, I'll tell you. A cosine t, still squared. But now the derivative of y goes here. It's this dude. See, it's these two that are flip-flopping. So I actually put another cosine over there, of all things. I'm actually just flip-flopping these two right there. And then you put a minus sign between them instead. So then the next one, 3a sine of t squared. And then I'm putting a negative a sine of t dt. I want to show you something about this next one, okay? Let me use a different color for a second. Like I said, this and this are flipping, like they're switching places, and then you just put a minus in the middle. So far, so good? So the same thing with this one. This and this are swapping, and then you put a minus in the middle. What happens when you swap these two and put a minus in the middle? What's the full result? Do you see it? 0 indeed. Because this guy's 0 is here, and this guy would be a 0 there. It would actually end up being 0 plus 0. So I don't have to keep going. I'm just going to say plus 0 to indicate like that half of it just is not going to do anything. Are y'all seeing that little swappy doodad I did? I'm trying to save time, but also concept, you know? It's concept. Okay, so yeah, now we're we're left with a huge mess. They all have a 3a cubed, and now I've got cosine what? Cubed. 2 negatives make a positive. Sine cubed. Eek. Nobody wants to do that. You told me you didn't want to do it because you spent an hour on silly little crescent moon problem, and I just deleted it. Gosh, I know, and Mason's upset about that because he went and did it. But how did you do that problem? Can you just remind me again? Huh? Yeah. Okay. Nice. I love that. See, decimal equivalent and all that stuff. Were you saying you're using Desmos? Oh, Desmos graphing? Oh my gosh, Desmos graphing? Wait. Hold on. Pause, time out, guys. This is chapter 16. This is on the final exam only. Now we have license to use Desmos graphing. I know. It's only been like months. And so I want to put this dude into Desmos graphing because why not at this point? Nobody wants to do cosine cubed, right? And neither does Desmos. So nobody wants to do cosine cubed, and neither does Desmos. Isn't that a want?
Yeah,
Really?
The funny thing is, you can multiply it by a cosine, and it works perfectly fine.
Well, of course. They're just upset about the notation. So you do this, and everything's happy again. That's not it. Yeah, I know. It's just so silly. So now you can see the notation we need. So what we have is 3a cubed times 4. Man, that was so much easier. Could we have done that by hand? Sure. Do you want to do it by hand? Exactly. Especially at this point. Flash the answer. And, you could see I did the same thing. I just went to Desmos with that guy. Did I get the answer? I got a... Okay. You want to know? I kept saying, oh, and I did it this way and I got the wrong answer. I did it this way and I got the same wrong answer. That's what I did wrong earlier. That's what I did wrong. I put it into Desmos thinking I'll only put the A in there, but I forgot that there was a 3 in the front. I always just, I would say like literally doubled my my scalar in the front. I doubled it every single time because I was being silly. I wasn't paying attention. And there it is. Now you know. Now you know my problem. Good? Okay. Whew. Thank you for spotting it. I was like so excited. 12, and it's not 12. This is not 12. Stop, Chad. We got, what, 7? Oh, 6 minutes now? It just clicked. Any questions on this guy? Are you happy about Desmos graphing now?
Oh, absolutely.
Oh, okay. That was a slower head nod than these two guys. Okay. Cool. So then I want y'all to use Desmos graphing on this one, huh? Go on. Now, this is the one I did not do before class because I just ran out of time. But what are they asking for? Is it? Is it the FDR or is it the other dude? Well, it doesn't matter about how many R's you have. It's about the word. So it's either flux or it's flow. And so, yeah, flow is the FDR. You're correct. So you can see that they're using these terminologies. You might want to know what the concept is behind flux and flow, and that's where my job stops, okay? I'm showing you how to integrate, and you can go discover that on your own. Good job, guys. Did that sound like a physics class? It does? You were spot on that one. Big man on campus. So. Oh, yeah. Sure. See, you know what? How about you want to record for the folks at home? I was half serious. I actually was. So yeah, this is just going to be integral FDR. and let's do this thing. So notice that we have an I and a.
Wouldn't that be like
Right. So my f vector, like when I start plugging in, I got x. Uh-oh.
no y's?
If there's no y's, what would my y equal? Yes. Yes. And then this is z. Here we go. So then I've got cosine of t minus sine of t. What do I have here? There it is again. And then z is just sine. Okay. I already have my r, but I want my r prime. Derivative of cosine? Derivative of 0?
Still 0.
And derivative of sine?
Cosine.
Sweet, sweet. So then when I dot product these guys, I'm going to say it's negative sine of t times cosine of t minus sine of t plus 0, I suppose. And then we got sine times cosine dt. They already gave me a t, 0 to pi. Yeah. Yeah. I'm just being, I'm just a teacher. Just being a teacher. What do you do at this point? Distribute? Trig identities? No, don't say that. No, Desmos. Sheesh, we just talked about this. Didn't we?
Yeah.
I know, this class.
It's hard to break bad habits, okay?
Yeah, I know. Yeah, true that. Yeah, it is hard to break the habit, but you need to now because it'll only get harder going forward. So your answer here is pi over 2. Bam! I'm going to flash the answer to prove it. What, you didn't see that? If you can't see that, then you need to do it by hand, okay? as a slap on the wrist. Huh? Come on, Cal 3. Where have we seen that number before? Where have I taught you that number from my YouTube videos because you didn't take me for pre-cal? Oh, for reals? Whoa, well then, as you know, I've been using decimals for a long time. 1.57 pi over 2. You already know it. 3.14. Okay, 6.28. 4 point, I can't remember exactly. So, I mean, but these numbers are important, right? 7071, 0.7071. Yeah, 0.7071. No. Square root 2 over 2.
Can we also just divide by pi as well? Just get the 1.
Boo, bro. Boo. Because you know there's going to be a pi in the answer. You want to do it this way, huh? Good job. Hi there. So, yeah, fine. If you want to be that way. But as you can see, now that we got Desmos, this class will be boring. But at least it'll be fun. Fun and boring. Good? Any questions? We're good? I'm done. Thank you, guys. Another great day.